Hey, good afternoon, everyone. It's your friendly math teacher, Mr. Kong, here today to talk to you about section 6.5, solving radical equations. Okay, guys, there are two types of equations that we're going to look at. Equations with only one radical in them, and equations with multiple radicals, like two radicals in them. Ladies and gentlemen, here are the steps for solving one radical, as you can see right here. Take a look at all these steps right here. You can go through those on your own time if you want to pause the thing. And then there's solving two. If you want to look at that, you can look through all these steps on your own time as well. Okay. All right, guys. There's going to be something called extraneous solutions again in this one. We'll talk about why here in a second. An extraneous solution, don't forget, is a solution that when you plug it back into the original equation, doesn't make sense. You know your math is right, but for some reason your answer doesn't make sense. So let's look at some examples where we're solving for x. Take a look at this first example. I've got 5 minus the 4th root of x equals 0. Well, guys, let it make sense. I'm just sad mapping here. I only have the one radical in the problem, so I've got to get that x alone. Well, to get the x alone doesn't make sense. I'll move the 5 across first by subtracting 5. I get the negative 4th root of x equals negative 5. Now divided by negative 1 to get rid of the negative, I get the 4th root of x equals positive 5. And then what's the opposite of the 4th root of x? Well, again, the reciprocal power of that would be raising it to the 4th power. But that's the opposite thing, right? So raise both sides to the 4th power, and I get x equals 5 to the 4th power, we all know, is 625. Now, let's check and make sure that this works. If I plug 625 back into the original problem, I need to make sure that that makes sense. Well, what is the 4th root of 625? Well, it's 5. And 5 minus 5? 0. So that works, so that's my answer. Take a look at the next example, example B. Here, I subtract 2 to isolate the radical. I get the square root of x equals negative 2. I square both sides to kill off that radical. I get x equals 4. Now let's plug 4 back into the equation. I get, the square root of 4 is 2. Well, but that's positive, right? What's 2 plus 2? 4. 4 doesn't equal 0. Wah, wah. That's no good. So that doesn't work. Since 4 is the only answer, well, if that's the only choice I had, then there must be no solution to that. Okay, and that's where you have to check and make sure and be careful, right? So take a look at this next one. I've got 3x to the 4 thirds equals 243. My first question is, who's getting this 4 thirds power? The 3 and the x, or just the x? That's right, just the x, because there's no parentheses. So the first thing I'm going to do is divide both sides by 3. When I do that, I get x to the 4 thirds equals 243 divided by 3 is 81. Now to get this x alone, don't I have to get rid of this exponent? Well, to do that, don't you think I could raise both sides? And don't really focus here. I know if I give this guy another exponent on the outside here, won't this exponent multiply by this exponent? Well, I'm going to choose an exponent that would make this 4 thirds turn into a 1. Now, you might say, well, golly, how do you do that? Well, all you have to do is pick the reciprocal of that fraction. The reciprocal of 4 thirds is 3/4. Check this out. If I multiply, because I know when we have an exponent on the inside and an exponent on the outside, we multiply them. What's 4 thirds times 3/4? Well, we can dance with the 3's, we can dance with the 4's, and you're left with 1. Ah, beautiful. Don't they just cancel out? So I'm left with x on the left. But if I raise the left side to the 3/4 power, I must raise the right side to the 3/4 power, right? Now, again, a lot of you aren't comfortable thinking about rational exponents, so you want to convert that back into radicals. Doesn't that say that's the 4th root of 81 to the 3rd power? Now, again, I can either put the 3 inside, or I can put the 3 on the outside. Well, if you put it on the inside, then that means you have to cube 81. 81 times 81 times 81 is, Lauren? Yeah, none of us know that, right? So let's put 81 on the 3 on the outside, okay? Well, if I do that, I would get x equals What number times itself 4 times is 81? Oh, 3. All right, and I got 3 cubed, correct? From there, I just cube that, and I get x equals 27. Now, folks, I'm going to tell you right here, right now, your hero, Mr. Kong, has made a mistake. Somewhere in here, somewhere in this region, there's a mistake. The first person to tell me that will get a prize tomorrow. Tell me what my mistake is, all right? All right, let's go to the next example. Example D, right here, right? I've got the 4th root of x to the 4th plus 1 equals 3x. Notice I've already gotten this radical alone, right? So all I have to do is do the opposite exponent to get rid of that radical. Well, doesn't that mean I should raise both sides to the 4th power? 4th power here, 4th power here. Don't forget you need parentheses because you got to raise that 3 to the 4th power. I get x to the 4th plus 1 equals, wouldn't that be 3 to the 4th, x to the 4th? Which would be x to the 4th plus 1 equals 81 x to the 4th. Everybody see how I got that? Now wait a minute. To solve, don't I have to collect all my x's? So I'm going to subtract x to the 4th across. When I do, I get 1 equals 81 minus x to the 4th minus 1 x to the 4th is 80 x to the 4th. Okay. Dividing both sides by 80, I get x to the 4th equals 1 over 80, and then I take the 4th root of both sides. When I do that, I get x equals, I got my x alone. Well, let's see here. The 4th root of 1 is 1. The 4th root of 80 is the 4th root of 80, right? For this class, again, I'm not going to make you rationalize that for now. We got bigger fish to fry, if you like frying fish. Now, that should be my answer, right? Hint, that I'm making the same mistake in this problem as I want you to look for in this problem. Think about it. Okay, let's look at this last example, call it E, right? I've got square root of x plus 7 minus 5 equals x. Well, again, I need to isolate that radical so I can get rid of that radical. So wouldn't I have to add the 5 across? I get the square root of x plus 7 equals x plus 5. Now, to get rid of the square root, I just square both sides. But I got to square the right side in parentheses. When I do this, I get x plus 7 equals, hey, don't I have to FOIL that? Wouldn't that be x squared plus 10x plus 25? Oh, wait a minute. Isn't that a quadratic? So I've got to subtract the x and subtract the 7 across. And when I do that, I get 0 equals x squared plus 9x plus 18. Now, what factors of 18 add to give me 9? You guys have good factoring skills. Wouldn't that be x plus 3 and an x plus 6? Yeah, I thought so. All right, so now just solving, I get x equals negative 3 and x equals negative 6. But wait a minute, shouldn't I check to make sure that these work? Let's plug a negative 3 in here. If I plug a negative 3 in here, negative 3 plus 7 is 4. The square root of 4 is 2, and 2 minus 5 is negative 3. And negative x was negative 3, so that works. So negative 3 works. Now let's try the negative 5. Okay? Woo! Woo! Whoa! All right? Plugging in the negative 5. All right? I'm sorry, the negative 6, my bad. I get negative 6 plus 7 is 1. The square root of 1 is 1. 1 minus 5 is negative 4. Right? Right? Now, plugging in negative 6 on this side, does negative 4 equal negative 6? It does not, so negative 6 doesn't work. So my only answer is x equals negative 3. Okay? I hope I'm not moving too fast. All right? All right, let's try some more examples. All right, in this next set of examples, I have problems where I have two radicals. Okay? So let's take a look at this. The first thing I need to do is I need to isolate one of the radicals. All right? The general rule is you always want to isolate the radical that has the most inside the radicand. So I'm going to isolate this radical first. So if I add over the 2 radical x, right? This will be what I want to do first. Now, why did I isolate this radical? So I can get rid of it. If I square this radical, I can do that as long as I square the other side, right? Wouldn't I be left with 12 minus 2x equals 4x? Think about it. I got to square the 2 and the radical x. Well, from here, don't I just add the 2x across? I get 12 equals 6x, so x equals 2. Making sure that if I plug this 2 back in, here and here, I should get 0. Well, let's see. 12 minus 4 is 8. So I've got the square root of 8 minus 2 square root of 2 equals 0. Is that true? Well, yeah, because this is 2 root 2, isn't it? And 2 root 2 minus 2 root 2 is, yeah, 0, right? B is like A. So you guys try that one on your own, and then we'll talk about it tomorrow. Let's take a look at C. In C, I've got the square root of x plus 6 minus 2 equals the square root of x. Again, which of these is the more complicated radicand, the x plus 6 or the x? The x plus 6. So I'm going to get him alone. I'm going to add the 2 across, and when I do that, I get the square root of x plus 6 equals the square root of x plus 2. All right, yeah, sorry about that. Let me restart this problem. I was hallucinating there for a second. Let me go back and retry this again, guys. Yeah, what I want to do on this is get this square root alone first because he's got the more complicated radicand. All right, so to do that, I'm going to add the 2 across, and when I do, I get the square root of x plus 6 equals the square root of x plus 2. Now, the reason why I got this radical alone is when I square him, he'll cancel and give me just x plus 6. But if I square the left side, I've got to square the right side like that in parentheses. Now, when you multiply that out, you get x plus 4 square root of x plus 4. Now, I want to get this square root alone. I want to isolate him so that I can get rid of that radical by squaring. So I need to first start by subtracting the x and the 4 across. Subtract the x and the 4. And when you do, you get 2 equals 4 square root of x. Now divided by 4, I get 1/2 equals the square root of x. Squaring both sides now to get rid of that square root sign, I get 1/4 equals x. All right, now let's take that 1/4 and plug it back in to this equation here and see if the left side equals the right side. On the left side, I'm going to hit 1/4 plus 6 minus 2 equals the square root of 1/4, right? Well, 1/4 plus 6 is 25/4, all right, square rooted, minus 2 equals, well, the square root of 1/4 is, square root of 1 is 1, and square root of 4 is 2, agreed? On this side, square root of 25 is 5, square root of 4 is 2. 5 over 2 minus, well, 2 is 4 over 2, all right, is 1 over 2. Oh, wait a minute, 1/2 equals 1/2, so it works, so 1/4 is my answer, okay? You guys can try D on your own, okay? Normally I'd end here, but I got a little tribute on this special day, so if you want to stick around and listen, feel free. Mommy's here. Mommy's here, Ollie. Mommy's here. Her mother's here.
Is my mom?
Huh?
I was thinking about my mom.
Man.